Okay. Objective 6. Use inequalities to solve applied problems. Example 1. Sam has scored 95, 85, and 84 on his first 3 tests. If he wants an average of at least 90 after the 4th test, what score must he make on his 4th test? First of all, we need to let X represent his score on the 4th test. Whatever he needs to make on the 4th test, we'll let X be that, represent that score. So, remember we're trying to get an average of at least 90 on 4 tests. So, first we have to account for the sum of all 4 tests. The first one being 95, the second one 85, third one 84, and the 4th one unknown. So we write 95 plus 85 plus 84 plus X divided by 4, because remember there'll be 4 tests, and that quotient represents an average. And since the average has to be at least 90, we use this symbol greater than or equal to 90. And thus we have an inequality that needs to be solved for X. Well, there are several different steps you can take from here, but what I'm going to suggest first is that we get the sum of the 3 tests already graded, and that sum becomes 264. Then we'll add the 4th test, which is X, to that, divided by 4, and again that average must be at least 90. Next we need to get rid of the fraction, so we need to multiply both sides of this inequality by 4. Upon doing that, the 4's on the left side cancel, giving us the quantity 264 plus X is greater than 360. Then we need to isolate X on the left side by subtracting 264 from both sides. That results in our final answer, which is that X must be greater than or equal to 96. That means that Sam must make a score of 96 or more on his 4th test in order to have an average of at least 90. Example 2. When 10 is subtracted from the sum of 4 times a number and 8, the result is less than 16 more than the number. Our challenge is to find all such numbers. Once again, we will let X represent the numbers, and therefore we have to construct an inequality that reflects the statement we just read, or the problem we just read. And therefore we have the sum of 4 times X plus 8 minus 10 is less than X plus 16. That inequality reflects the problem that was posed. Next, we have to try to solve this inequality for X by looking at the left side and simplifying somewhat. And so we have 4X plus 8 minus 10 is less than X plus 16, and 4X minus 2 is less than X plus 16. Next, we'll subtract X from both sides, giving us 3X minus 2 is less than 16. Again, isolating the X term, we have to add 2 to both sides, which produces the inequality 3X is less than 18. As a final maneuver, we need to divide both sides by 3, getting X is less than 6. Therefore, the numbers that we're looking for are all numbers less than 6. Example 3. The formula for converting Celsius temperature to Fahrenheit is F equals 9 over 5 times C plus 32. Suppose the Fahrenheit temperature of Fort Worth, Texas has never recorded 122 degrees. How would you describe this using Celsius temperature? Well, first of all, we need to translate that information into an inequality. And therefore we get the inequality 9 over 5 times C plus 32, which represents Fahrenheit, is less than or equal to 122 degrees. Again, we're trying to solve for degrees Celsius, which is C, so we'll subtract 32 from both sides. That produces the inequality, 9 over 5 times c is less than or equal to 90 degrees. But once again, we're trying to find out what c is, not 9 over 5c. So we have to get the reciprocal of 9 over 5, which is 5/9, and multiply both sides of this inequality by 5 over 9. And upon doing that, the left side becomes exactly c, and it should be less than or equal to the right side, which simplifies to 50. Therefore, this degree Celsius has never exceeded 50 degrees. Example 4. Suppose a rental car company charges $20 a day to rent a compact car, plus 10 cents a mile. If David can spend no more than $30, what is the maximum number of miles that he can drive in one day? Well, let's let x represent the maximum number of miles he can drive in one day. And therefore, we want to figure out, set up a cost equation. So we can say that the cost will equal to $20 plus 0.10 times x. Consequently, we write as an inequality 20 plus 0.10x is less than or equal to 30. Now, isolating x, we'll subtract 20 from both sides, getting 0.10 or 0.1x is less than or equal to 10. Then dividing both sides by 0.1, we obtain the final solution that x is less than 100. Therefore, the maximum number of miles is 100 that he can drive in one day.